Hello, I'm Jim Salisbury with Mitsutsuya America Corporation, and welcome to the Metrology Training Lab. In this episode, we're going to revisit the calibration of calipers and look at a specific issue with dial calipers. In a past episode, we thoroughly covered the calibration of calipers following the guidelines from the American National Standard ASME B89.1.14. In that episode, we focused on the more popular digital caliper, and we missed discussing an issue that's important to consider for dial calipers. So first, let's do a very brief review and summary of the general calibration method for calipers. I'm going to first use a digital caliper, and I'm not going to try to be particularly precise in this example, so please forgive me for that. For the outside jaws, we take a series of measurements over the measuring range. 1 inch, 2 inch, 4 inch, 6 inches, and we also vary where we are across the jaws. Then we do an inside measurement, 1 inch like this. Then for the depth bar, we do a measurement like that. This caliper has a step function, so we do a measurement like that. And then to make sure that we don't have any problems with the small inside knife edges, we measure a 200 thousandths ring gauge like that. I'm going to now repeat some of those same measurements, this time using a dial caliper. I want you to look closely at the angular position of the pointer in the dial during these measurements. So I'm going to repeat the same outside measurements as I did with the digital caliper. So at 1 inch, and notice that the dial is at the 12 o'clock position. I go to the 2 inch, once again, the 12 o'clock position. I go to 4 inches, again, 12 o'clock position. I go to 6 inches, again, 12 o'clock position. Inside measurements, once again, the same position. I could show you that for the depth and step and for the ring gauge. All of those, the pointer would be at the 12 o'clock position on the caliper. Now, dial calipers use little gears inside, and the gears can wear. It's possible for there to be errors within a rotation of the dial that you won't see if the calibration method results in the pointer always being at the 12 o'clock position like you just saw. For this reason, the ASME B89.1.14 standard requires some test points that put the pointer in additional angular positions, so they're not always at 12 o'clock position. So for an example, I have two gauge blocks that are rung together here. So this is a 125 gauge block, and this is a 150 gauge block. These are standard blocks from any set of gauge blocks, so most people have these. For this style caliper, this inch size caliper, with the 125 block, if I was to measure that, I should be at the 3 o'clock position like you see here. If I measure the 150 block, I should be at the 6 o'clock position like you see here. And if I measure both blocks that are rung together, I should be at the 9 o'clock position. So these two gauge blocks rung together give me 3 additional easy test points. Not too difficult to test the accuracy of the caliper with the pointer in different angular positions. The ASME B89.1.14 standard does not prescribe specific test points, so you have lots of flexibility here. But we wanted to show you at least one option, one way that does the job, and it's pretty easy to implement. That's everything for this episode. Thank you. I'm Jim Salisbury, and I'll see you next time from the Metrology Training Lab.